So it's a privilege for me to be here. As Sandali said, I was a past president of the Rotary Club of the Faculty of Science, University of Colombo as well. So fond memories being here. Just a kind of a quick topic check. So the topic that I'll be talking about today is data-driven decision-making and data science in the modern world. Sorry about that. Unfortunately, I think the flyer that went out had a slightly different topic, which mentioned Fortune 500 companies. Although I work in a Fortune 500 company, Amazon, unfortunately, we are not allowed to talk about the business decision-making within Amazon. At least I'm not pre-approved to do that. So if some of you have joined specifically to listen to decision-making at Fortune 500 companies, I'm sorry to disappoint you, but I won't be able to talk to you about that. But instead, I'll be talking about data-driven business decision-making in smaller companies. And I think there's a lot of overlap between these small companies and small teams within larger companies and how they do their decision-making process. So there might still be value for all of you who are interested in the larger companies as well. And the second half of my talk is also going to be dedicated to talking about some of the data science that goes on in the modern world as well, and I'll pull from my experience here. So a quick disclaimer before I start, the opinions that I expressed here are mine and mine alone, and do not represent those of Amazon or any of my other previous employers, present or past. Okay, to start off, let me quickly talk about a comparison between large versus small companies. So in large companies, typically, if you're an employee in a large company, let's say you're a data scientist, usually you have the opportunity to get more specialization in your field. And you also have more opportunity. Specialization because there's so many people doing so many different jobs that you can actually concentrate on your own kind of section and dive deep and get a lot of experience in it. And the other part, more opportunity, because there are so many teams that kind of that work in these companies that you can switch around, get a lot of exposure, and kind of grow yourself. Downside of working in a large company usually is that it's more bureaucratic. You have to kind of jump over a lot of red tape and basically do a lot of things to get any small thing done. So typically it's a little slower than smaller or medium companies. And also you tend to have lower impact because there's so many different people who are working. So it tends to be a little bit, your work tends to be a little lower impact. In the smaller company side of the sphere, usually you have better work culture. You have like this familial kind of field where you kind of, it's a small family of like maybe 10 members who are kind of working to bring a product into the market. So there's a lot of camaraderie. You have more exposure typically. Just because you're a data scientist, it doesn't mean that you can just skip the software engineering part. You might have to just build code and deploy production level code. So you wear multiple hats. You definitely have high impact because the code that you write today might have to go to production tomorrow. Whereas in a larger company, it'll go through code reviews and production release cycles that can take weeks. The downside of smaller companies, of course, is less specialization. It's essentially so quick that you need to kind of do the thing that you need to do immediately because you're probably the only one who's there to do it. So you have less time to specialize in certain kind of areas that you want to. And of course, small companies tend to be a bit unstable, some go under, so you always have that risk. So is there a middle ground? Yes. So from my experience, some large companies are beginning to become more agile and flexible, especially at team level. So FANG, for example, FANG stands for Facebook, Amazon, Apple, Netflix, Google, and the term FANG was coined to signify some of the highest performing stocks at a given time. So in the FANG companies, you find that they tend to have small teams which are more agile, more flexible, and sort of function as small companies themselves. So for example, the small company will have customers who are their actual customers. But in FANG companies, these small agile teams have other teams as their customers. Well, there'll be customer-facing teams that have actual customers who they serve. So all this being said, what I'm trying to say is the decision-making process in small companies can actually apply to some of the agile, larger companies, small teams as well. At least that's my experience. So that's kind of where this talk has been structured from. Okay, so I want to just talk at the onset, I want to talk about a few quick things to avoid when you're using data in general for decision making. And this can be common to entrepreneurs, data scientists, and data analysts, or whoever uses data. So here are some pitfalls. Assuming that data is clean, not normalizing, excluding outliers, including outliers, and I'll get to it in a minute why there are both sides of it, ignoring seasonality, and ignoring size when you report growth. So, for example, here are some examples. So let's say you get a data set, and as research scientists and engineers, the first thing that we want to do is we want to just throw that data into a machine learning model, our favorite model, pick up random forest or XGBoost, just throw that in, and then you want to predict something, right? You don't really take time to actually look at the data, and that's a big mistake. Let's say, in some cases, you might suddenly find that 30% of your data is null. Is that accurate? Is that a systemic issue? Well, you should find out. It has to be cleaned. A common kind of mistake is, you have these, let's say you have a pandas data frame and you're trying to group by states, for example. When you look through that data frame, you'll suddenly find that, New York is represented in 3 different ways: as New York, as NY, and as New York in simples. So your group by is going to group by three different strings because it thinks, oh, there are 3 different categories, but actually you want 1 category. So here are examples where you need to kind of clean the data ahead of time before moving forward. Not normalizing is another big offense. Say, for example, we're trying to find out which district in Sri Lanka is most popular for Nike shoes, like which people in which district likes Nike shoes the most. So the easy way to do it might be to just count the number of people who buy Nike shoes within a district, within each district, and just plot it. But this is a mistake because this will only give you, or most probably will give you, the highest populated districts. So you need to normalize by the district population in order to get the proper value. Excluding outliers. So let's say, for example, you're hosting a website and you want to find out, you have some users, you want to find out how many times does a user visit my website per day? And when you look at it, you suddenly find that there are these 10 users who visit my website thousands of times a day. Who are these guys? So they could be your greatest fans. They could be like big fans who really love your website and visit it like thousands of times a day. Or they could be just bots crawling your website. Either way, you should probably not ignore them. You probably want to know qualitatively what these points are and kind of get that information because it might be helpful at some point. But you should also probably not include them in your machine learning model. Because let's say you have a recommendation system and you include this data in your recommendation system, the recommender will start recommending for everyone what's being bought by these greatest fans or what's being clicked on by the bots. So that's not the best thing either. So either way, there are kind of 2 different cases where you have to exclude outliers or include outliers. So in the US, usually, this June period of summer is where internships are really popular. So if you look for, popular jobs in June on Google, you're going to immediately get intern. But if you're trying to answer the question, what's the most popular job of the year, and you're looking in June, you might just think it's intern, but it's not. It's just intern because it's June. So you have to remember seasonality when you are trying to answer a question based on data. And then finally, ignoring size. Say, for example, you have a website and last week you reported, oh, I had 100% increase in visitors to my website last week. And then you realize the previous week, you're the only one who visited the website and then you told your father about it, and he clicked on your website last week. Well, that's 100% increase. But does that really matter? Is that what you want to represent by 100% increase? So it's very important to specify the size of your user base when you're reporting growth. So with that, let's kind of move on to this kind of lean startup idea. So I'm kind of using this diagram from this book called Lean Startup, which I suggest for any kind of entrepreneurs who would be budding entrepreneurs. And also this specific diagram is from Lean Analytics, written by Kroll and Yoskowitz. So it's also a great book, which I highly recommend. So there's this concept of build, measure, learn when you're trying to take a company to market, or when you're trying to take a product to market, right? So let's say you have an idea, you want to build something. Okay, you have an idea, you build it, you get a product, and then the next step is you need to measure that product. You need to measure how it performs. You get data from your measurements, and then you learn from that data, and then you go back and perfect your idea. So there are a few things that kind of get that people get hung up on here. Everybody thinks that their idea is the best idea, and that's perfectly natural. So they jump in and start to build it. But spending a lot of time on building also might not be the best thing. So for example, if you spend too much time and effort in building a product and you suddenly realize that it's not the best for your customers, it's not going to work for you. And you tend to usually be biased towards your product, right? You might not be in line with what your customers are asking for. So it's important to build an MVP, or a minimum viable product, and quickly take it to your customers and see how they respond. So you can identify your early adopters and who the people are that have potential to use your product. And then you measure that. When you measure, you suddenly realize things that you probably would not have thought about. So you say, oh, this product might not be the best product for my customers, or my model might not be the best for my customers. And then with those learnings, you can take a decision. You can either pivot to a different market or to a different product, or you can persevere and say, no, you know what? I'm going to keep studying, kind of doing what I'm doing, and see whether I can grow it. And if you're persevering, usually you identify a key metric at the given stage of your company, and you optimize to that metric, and you try to make your product better and better and better towards that metric. But at some point, if that metric does not work, and if you suddenly understand that your business model is not working, best idea is to pivot or to start again. So with this idea, I want to kind of step into several case studies and kind of identify how these startups that I'm talking about handle these sorts of problems. But before we go there, let me kind of state one more thing. I want to talk about data-driven versus data-informed, and we're going to talk about this in our case studies as well. So what's data-driven and data-informed? So, the new thing with startups is all founders are told, oh, you have to be data-driven. You need to kind of use a metric, you need to optimize to a certain metric. This build, measure, learn cycle works really well, and that's the way to do it, because you need to be unbiased from your kind of, personal emotions and emotional decisions. But some founders tend to think, no, that's not true. My company has to have a soul. Everything cannot be data related. I need to kind of take some decisions that cannot be given by the data. And so they prefer to be data informed. So there's no real correct answer. One opinion might be, I think data driven is the way to go. It's a very good way to keep your company kind of improving and making correct business decisions. But in certain cases, it's very good to step back and look at the big picture, kind of be data informed, and take a decision that your data-driven model might not give you. So let's take, for example, this very common mathematical analogy where your model is trying to look for a minima. So you have your solution landscape, and your model is converging towards a minima. So let's say, it's kind of like you have this slide and you drop a marble in it. Where does it land? So if you're on the left-hand side of things, your model is going to optimize towards a minima, and it's going to end up in the local minima, because your model can only optimize to the problem space of which it's aware of. You might not find the best solution using that data-driven model. So for that, for example, in order to find the global minima, sometimes you might need to step back, look at the bigger picture, and then try again. So here's another kind of analogy for it. Say, for example, somebody gives you 3 wheels and tells you, you know what, optimize for stability, okay? So you build a machine, or you have some data-driven process, and you try to figure out what's the most stable configuration. So your machine tells you, your machine says, oh, you know what, let's put 3 wheels in a line. Nope, it doesn't work. Let's put 2 wheels and 1 in the left, or let's put 2 wheels and 1 in the right, and it kind of keeps on shifting. And then finally it arrives with the most stable configuration of a tricycle, right? So you have 3 wheels and you have a tricycle. And this is the same configuration that Benz arrived with in 1886 with this beautiful looking Benz tricycle. Now that's stable, and that's data-driven. But one thing that your data-driven model is not going to do is kind of step back and tell you, you know what, if you go give me a 4th wheel, I can make it way more stable. That's not going to happen. Your model is not going to do that. That's something which you have to do with human intuition. You have to step back, you have to look at the bigger picture and realize, oh, you know what, a 4-wheeled Benz is probably more stable. Okay, so with that, let me go to this first case study that I wanted to talk about. So this is about a software as a service company, and it's called Backupify. Super weird name, but you know what, like these startups have very interesting names. So this was called Backupify. It's actually a real company, trust me. So Backupify is a backup provider for cloud-based software, for cloud-based data. And when it started, it initially focused on optimizing for site visitors, then for trials, then signups, and then finally monthly recurring revenue. It also tracked customer lifetime value and customer acquisition cost, all metrics that it's trying to optimize to at different stages of its life. Now, the challenge for Backupify was once it got to tracking customer acquisition cost, it realized, or at least the data told it, that its customer acquisition cost was way too high. It was spending $253 to acquire a customer who paid $39 a year. That's terrible, because what does that tell you? It takes you at least 6 years to win back your acquisition cost, and that's not good. So what was their solution? They decided to pivot. So they pivoted to from consumer sales to go after businesses, and it ended up being a great success. So what can we learn from this little example? So first of all, it's important to optimize to the right metric at the right time. That's a data-driven process. So in this case, Backupify optimized to site visitors, trials, signups, and monthly recurring revenue, and they grew their customer base successfully. And then they got to more sophisticated metrics. And second thing that we learn is when you get to more sophisticated metrics, you might find out that your model is actually not sustainable. That's also data-driven because your data is showing that your model is not sustainable. But at that point, you can try to continue to optimize to customer acquisition cost and keep going and keep trying to optimize. Or you can be data informed and step back and say, you know what, I have to pivot. And in this case, that's what Backupify did. So they stepped back, they looked at the business, and they realized that they need to go for a new market. They might have also been kind of thought of like giving up or starting from scratch. But luckily for them, they thought of this new market, and it was a great success. So here's where you kind of step back and look at the big picture and make a decision. So our case study 2 is on an e-commerce site called wineexpress.com. So if you click on wineexpress.com, you'll see it now itself. It's still there, and they have this really nice wine of the day page. It's actually very successful, even during the time when this case study was actually written. So this wine of the day page has a wine which is projected on their page for a specific day, and then they have this video next to it, which has a wine expert from wineexpress.com doing a virtual tasting. So it's very nice. He gives you like an idea of what the wine tastes like, and it's great. So lots of people really loved it. And there was a lot. It was a successful page. But wineexpress.com wanted to make it even better. So they wanted to develop and execute a strategy to improve performance on this page. So that was their challenge. And so their solution for this was they engaged a conversion optimization agency called Wider Funnel Marketing. And they used A/B testing to test different layouts for this page. And ultimately, it was a great success. So what can we kind of learn from this example? So first of all, the first thing that kind of pops out to me is they engaged Wider Funnel. So, probably they didn't have the in-house talent to do the A/B testing that they wanted to do, and maybe they had the funds, so they decided to outsource it. But in any case, it's important to understand that sometimes you don't need to do everything in-house. You can just go outside and get a service for your company if that's the best thing to do. If you don't want to spend on it. Other times there may be value in just building it in-house in case you want to kind of use it on a long-term basis. So these are kind of decisions that you have to make intuitively. The second thing is they used A/B testing to figure out the best layout for their page. Now, this is a very data-driven process. It's a tried and tested method. Any company, you name it, Google, Facebook, all the big sites use A/B testing, and it's a great method to use. So that's a data-driven process. The other thing that I want to specify, and I didn't mention this earlier, is these guys actually focused on the right metric. So their biggest success here was that they increased their revenue per visitor by 41%. And so this is a great improvement, but they could have easily concentrated on the number of conversions. So what is a conversion? So conversion is, you have the wine of the day page. If you have a user who clicks on this page and then buys a wine, buys something, that's called a conversion event. And a conversion event can be any product, however you define it, right? But you can optimize your process to conversions, but that might not necessarily improve your bottom line. What I'm saying is, say you have a certain revenue level. If you optimize to your conversions on this wine of the day page, maybe you'll optimize people to just come and buy anything, something small, right? And it might actually negatively hit your revenue. So these guys actually understood that, and they optimized towards increasing revenue per visitor. So they wanted to optimize towards having one person click and buy something larger than they were buying before, or like more expensive, or spend more per visitor. And this worked extremely successfully for them. They increased the revenue per visitor by 41%. And in the process, they also increased conversions as well. So this was a success story for Wine Express. Okay, so let's move to case study 3. So case study 3 is another software as a service company called ClearFit. So the backstory here is ClearFit is a recruitment software aimed at helping small businesses find job candidates and predict their success. So ClearFit founders started off with a monthly subscription-based model. So basically what they said was, everybody kept telling them that if you're running a software as a service company, your key metric should be monthly. Your key model is monthly subscriptions. You have to go for monthly subscriptions in order to succeed. So they thought, okay, the key to success for SaaS is a monthly subscription model. And they did that. And they kind of had this monthly subscription at ClearFit, which was $99 a month. So ultimately, it didn't work for them. And here's why. So the challenges ultimately was the model was incorrect. So finding the right model. And also the price point was incorrect. Finding the right price was also a challenge. Why? So first of all, they suddenly realized that who their customer was. Their customer was small businesses, right? So small businesses generally don't tend to hire year out. Like they're not like big companies who have HR arms which hire across the year, right? They are hiring sporadically. And those customers could not make sense of paying $99 per month every month to just hire people, something that they did sporadically across the year. And also, they were used to these job boards. Usually, these small businesses, what they do is they post a job posting on a job board. Each job posting costs about $300. And then they get their candidates and interview them, and that's it. So they're so used to this model, they did not want to kind of move to this $99 per month monthly subscription. So they were like, why do I want to pay $99 a month? And the other thing that was really weird for them is they were so used to this $300 price that when they looked at $99 from ClearFit, they were a bit skeptical of the value, right? Now think of Nike shoes again. I love Nike shoes, right? Let's say I want to buy a pair for $120. So Nike pair costs about $120, right? If it's on sale, it'll cost $100 or $90, and I'll be like, this is awesome, I'm going to grab it. But if I see a Nike pair for $20, I'm going to be a bit skeptical. I might not buy that pair because I'll be like, how can I get a Nike pair for $20? I'm not very sure whether this is high quality or whether this is even Nike. So what does that say? That says that we are kind of looking at a product and expecting a certain price. We associate price as part of that product. And so that's what ClearFit's customers were doing. So ultimately, they reached a solution. They changed to a per job fee of $350, and immediately their sales tripled. And it went on, I think, to kind of grow the company 10x or so. So what do we learn here? First of all, they optimized to revenue. They got data and they realized that their model was not correct. So this is a data-driven process. And then they kind of interviewed customers, found out that their price point was also not correct. Once again, it could be qualitative interviews, which are human interactions, but also quantitative. So it could be a data-driven process. And then they increased their price point to $350 and changed their model to a per job fee. This is intuition. So you step back, you look at the picture, you realize something's not right, and you take a decision. And so the takeaways here is people don't do subscriptions for some things like haircuts, hamburgers, hiring, right? Like these are things which we do all the time, but we don't want to pay like a monthly subscription for it. So it's important to understand that. And if your business, if your product falls into those lines, you might have to price it or to choose a model that is correct. And then also you have to understand about how your customer values the product. Just assuming that the lowest price is going to work is dangerous. It might not, and the customer might undervalue your product. So you need to understand that. Okay, so that kind of brings me to the end of these 3 case studies that I spoke about. And with that, I'm going to wrap up the data-driven business decision-making part of it. And these decisions, usually they can apply to at a company level. It can also apply at a small team level in a large company as well. So for the next part of my talk, I'm going to talk about some data science in product, right? So what we talked about was data-driven processes and data science in kind of measuring how your company is doing. But on the other side, we also have data science in products. There's a lot of data scientists and machine learning engineers who build stuff, right? So we can have data science in product as well, and that's what I'm going to talk about. But before that, let me just quickly kind of define data science. It's always nice to go with the definition. So first of all, data science was a word that was coined by William Cleveland in a 2001 paper. And the kind of position data scientist is attributed to 2 people, DJ Patil and Jeff Hammerbacher in 2008. I think they were part of LinkedIn and Facebook. And so data science is an interdisciplinary field that uses scientific methods, processes, algorithm systems to extract knowledge and insights from many structured and unstructured data sets. Typically, it's built on applied statistics, and it has been used in the pure sciences for years. Things like physics, biology has been using this for years. But this term data science became buzzword recently when these companies realized that they had a lot of data, a wealth of data with no way to tap into it. And they started hiring these teams to kind of bring out that insight. That's how it became popular. Okay, so for my examples, I'm going to kind of draw from my past experiences. I'm going to talk about two cases where we've used data science in products. So the first case is going to be in the healthcare domain, and I'm going to talk about a product that we created for optimizing member conversion for breast cancer screening. And in the second case, it's in the advertising technology domain or AdTech domain, where we created an innovative incrementality testing method. So let me just quickly give a backstory for this healthcare example. So in the US, it's slightly different from Sri Lanka. In Sri Lanka, you want to go to a doctor, you go to the hospital or you go to a dispensary and you pay for the doctor and you get your treatment, right? But in the US, it's slightly different. You have to have health insurance, and health insurance is a huge, huge deal here. Usually, if you're employed by a company, the company provides you with health insurance, and that health insurance is ultimately provided by a health plan. There are many health plans, and it's a health plan that ultimately provides the person with insurance. Now, when you get older, or if you have certain disabilities, you fall into these other there are these projects called Medicare and Medicaid, which are handled by the government, and the government pays these things, and they are dispensed again through these health plans. So if you're a sick person, or usually if you're sick, if you have some condition, it costs you money, right? Like it costs you money, we all know that. But in this case, in this model, it costs the government money as well, especially for old and disabled people. Like if you get sick, it costs the government money. So the less sick people you have, the lesser the government has to pay. So we kind of come to this famous quote, prevention is better than cure. So preventive measures are much cheaper than actually treating a sick person when that person goes to hospital. So the government is kind of pushed to kind of make sure that people take these preventive measures and not get sick. It's awesome. It's a win-win situation. So it's great. Let's take breast cancer screening, for example. So if someone goes and gets a screening done, they might actually detect any complications at an early stage, and it might be much easier to treat than actually waiting for the last minute and then going to hospital and finding a complicated situation where you have to actually enter hospital, have operations, etc. So what does the government do? The government actually wants people to get these preventive measures because it's cheaper for them. So they decide, you know what, we're going to give health plans an X dollar bonus if they get a certain percentage of people to convert for a certain measure. Now, when I say measure, it can be anything. It could be taking your colonoscopy, it could be breast cancer screening, it could be a whole bunch of stuff. But for the sake of our example, let's stick with breast cancer screening. So let's say if the government gives X bonus to a health plan, and they say, hypothetically, that they need to have 95% of the women in their health plan to take this breast cancer screening in order to get this bonus. So this gives a win-win-win situation, because if you get 95% of your women to get the breast cancer screening, it's great for the members because they're preventing themselves from getting sick, or at least catching their issues earlier. It's great for the health plan because the health plan gets money, and it's great for the government because the government saves money. So it's a good system. So let's kind of place this example. So we have a plan A, a health plan that has 100 women, hypothetically. Let's say 90 have already converted for breast cancer screening, and they need 5 more to convert. And let's kind of create this hypothetical list of people, members, and their names. Funnily, they're all from sitcoms, but let's leave it at that. So we have, our health plan needs 5 of these members to convert for breast cancer screening. So what are the options that it has? So one, it can just call all of them. Okay, so sure, calling 10 people is not a big deal, but when your member list goes into the thousands and thousands, it actually does become a big deal and becomes expensive. And health plans don't want to spend all of that money. Even if they get that X dollar bonus, they want to make it as efficient as possible. So this is too expensive. So then the next option is calling a random number of people, less than 10, and seeing whether they will convert. So now this is good because it saves money for the health plan, but it's also bad because there's no information of like the likelihood of people to convert that who you call. So you could call someone, but that person might not necessarily convert. And if you call only 5, you might actually not get to 95 if someone doesn't convert. If you call higher people, obviously there's more likelihood of getting to 95, but then again, your expense goes up. So there's a trade-off, right? So what's option 3? Option 3 is, well, you could either hire a company or hire your data science arm, use your data science arm to build a predictive model to associate a likelihood to convert for each of these members. And this is a solution that we built. So essentially, these health plans have information about these members. Let's say their comorbidities, their conditions, their socioeconomic background, their geographic location, their frequency to kind of visit the doctor, how often they take their medications. They have a lot of information. They could feed this information into a machine learning model, train it, and then predict a likelihood for a person to convert for breast cancer screening. Once you have a likelihood, you can rank by this likelihood, and then you can call a number less than 10 based on that information, and you can go from high to low. But note that, low to high. But note that in this case, you don't even have to call some people, because if you find that there are some people who have a high likelihood of converting, you don't have to call that person. It's wasted resources because that person is going to convert anyway. So you can leave that person as a sure check. And then you can call these middle people who might not convert, but given a call, might be likely to convert. So those are the people you want to call, because on the other end, you have people who you know that might never convert, like whether you give them a call or even if you go to their house, you might actually not get them to convert. So those people also you can avoid and save on cost. So this is kind of an example of using predictive analytics to save cost in the healthcare domain. Okay, so for my final example, I'm going to talk about an example from the AdTech domain. So first of all, what is AdTech? AdTech is digital advertising. So you have digital advertising platforms that enable advertisers to kind of bid and advertise on inventory available in real time. So let me give you an example. I'm sure you guys have seen when you click on a website and it opens and you see these ads popping up, right? So this is one example of AdTech in motion. You also have, like, if you have these streaming TV subscriptions, usually Netflix doesn't show ads, but if you have Hulu or other kind of streaming solutions where you kind of watch your TV, you have these ad slots that come in. Those are also served by digital advertising platforms for your information. But let's stick with the website thing, just for our example. So you click on a website, let's say it takes like about 1 second, probably sub 1 second to load. In that time, there's this huge circle that happens in order to get that ad that is targeted to you. So you click on the website and the website says, oh, you know what? I have this ad slot on this website of a certain dimension. This user is opening this website. I want to make some money. So I'm going to show that person an ad. And so it pings an ad exchange and says, give me an ad to show this person. and you can pay me for that ad. And I will give you the cookie ID and the device ID or any other information that I get from this user to you to do your thing. And so the ad exchange says, okay, I'll give you an ad. Let me first do an external auction. We call it an auction. So it auctions off this ad space to buyers. And these buyers are not human. They're actually other machines which bid on this external auction on the ad exchange. Your ad exchange could be Google, Yahoo, Spartex, all these companies which kind of host ad exchanges. And so the ad exchange hosts this external auction, and the people, the kind of entities or machines that bid on it are called demand-side platforms. They're the digital advertising platforms that we're talking about. And these platforms have real-time bidding engines that keep bidding on these external auctions. So what they do is they have an internal auction because every demand-side platform has a lot of brands, right? Let's say they have a lot of advertisers. And let's say, for example, they have Dove soap. This one DSP has Dove soap. So out of all its advertisers, it conducts an internal auction on all its campaigns and picks out, oh, you know what? For this information, oh, by the way, your user information was passed by the ad exchange to the DSP via what we call a bid request. So that information has gone to the DSP, and the DSP says, based on this information, I'm going to conduct an internal auction and come up with an advertisement that is most suitable for this user, and also a price to bid. And then it passes that advertisement and the price to the internal auction in the ad exchange, and the ad exchange conducts the auction. And if it wins at the ad exchange level, that ad is passed to the website, and the website puts it on your on the website that is loading, and within that 2 seconds you see an ad. So the whole process, especially from the demand-side platform, kind of takes about 150 milliseconds, and this happens millions and millions and millions of times a day all over the world. Okay, so from the demand-side platform side of things, how it looks is this. So basically, the demand-side platform has advertisers who come in, like Dove soap, right? And they say, you know what? I'm going to spend $50,000 on a Dove soap advertisement with you guys, the demand-side platform, run my campaign, target the proper users using your machine learning, and get me some lift, get me some recognition and lift for my brand. But sometimes they're like, they don't want to trust something, right? So for example, let's say the demand side platform just shows this Dove ad to 100 people. And let's say 20 of those people just go out and buy Dove soap. But what is to say that this ad actually moved them? How do we know? Maybe those 20 would have just gone and bought Dove soap anyway. We don't know that. So the advertiser doesn't know that. So advertisers usually come and say, hey, you know what? Show me the incremental value of me spending this $50,000 on your platform to show ads. So the demand side platform says, oh, you know what? Sure, we can do an incrementality test for you. So here's where an incrementality test comes in. What is incrementality testing? So at this point, you guys are probably saying, oh, yeah, this is an A/B test. Exactly, it is an A/B test. Essentially, what you try to do is you say, oh, you know what? Out of all the bid requests that come from this ad exchange to the demand side platform, and every time your creative, like this Dove brand wins, I'm going to randomize those bid requests. A certain percentage is going to go to treatment, and a certain percentage is going to go to control, right? And whenever it's treatment, I'm going to serve your ad. And whenever it's control, I'm going to serve a placebo ad, like, Save the Turtles, for example, right? Now, if you saw Save the Turtles and if you went and bought Dove soap, chances are you were going to buy Dove soap anyway. It's probably not because you saw the Save the Turtles ad, right? So that kind of creates a baseline for the baseline number of conversions of this user base that you're targeting. And then when you can take the people who actually saw the real ad and get the conversion lift, right? Okay, so what's the problem here? So the ideal scenario for A/B test is 50-50, right? Like we spoke about in our case study, that would have been 50-50, but hey, they're winning in both cases in that case study. In this case, the problem is this Save the Turtles ad is basically a creative that does not move the needle for its advertiser, right? So the advertisers really don't like doing that. So let's say like the demand side platform says, you know what, I'm going to put 80% of your bid requests in your brand, with your brand ad, and I'm going to target 20% with your control ad. But that 20% in this $50,000 campaign is going to cost $10,000 for the advertiser. That's $10,000 with kind of spent on a placebo ad, which the advertiser knows is not going to move the needle for their brand. It's very difficult to convince an advertiser to do this sort of test because it's a huge cost, right? It's not going to move the needle for their brand. So this is a problem. So the main problem is high cost. So this method is good, but the problem is the high cost because those placebo ads like Save the Turtles don't have a positive impact. So we built an innovative method which actually does this A/B test without paying for control. And here's how. So before I go into that, let me kind of So the method is actually called predicted ghost ads. So the first method is called treatment versus placebo. The second method that we built was called, it's a version of predicted ghost ads. The original predicted ghost ads method was published in a paper by Google, and Google uses this. What we took is we took this predicted ghost ads method and made it better and patented it. So we have a US patent on this. We also have a blog post in case anybody's interested in reading it. But for now, I'm going to just explain it from the Google point of view and explain the predicted ghost ads method. So here's kind of a diagram which shows the placebo case. And from this, we can go to predicted ghost ads. So we have the bid request, which comes in from the external auction. We have the internal auction at the DSP level, which is going to be won by Dove Soap in this case. And then we randomize it to treatment and control. In the case of treatment, we serve the actual creative, the Dove Soap brand, right? And it goes into the ad exchange and it either wins or loses. We don't know. So if it wins, we get back the user ID for which it won. And we can use that ID to go to the Dove website and find out after that ad was shown, did that person go and buy Dove Soap? And we get what we call a conversion. And so we count the number of conversions signified by this yellow spot and divide them by the number of impressions, or divide them by the number of people who actually saw the ad, signified by the green dot with the win on it. And we have a conversion ratio, right? On the control side, when we send the same thing, we basically send the Save the Turtles ad to the exchange. And if it wins, once again, we take the user ID and we go to the Dove Soap ad and see whether that person went and bought Dove Soap. And if that person bought Dove Soap, then that person would have bought Dove Soap anyway. So we take again the number of converters signified by the second yellow spot divided by the number of people who saw the Save the Turtles ad. And now we have a conversion ratio for the baseline. And we divide the two, -1, and that's our lift value essentially, right? So that's kind of the placebo case. Now, if you go to the predicted ghost ads case, the top part remains exactly the same. We get the bid request, the internal auction, the Dove Soap brand wins, we randomize treatment and control. In treatment, same thing. You take the Dove Soap ad, send it to the ad exchange. You know who wins because you get the user ID when it wins. And you also know who loses because you don't. And you have this information of win and loss at the ad exchange. And what we do is you can train a machine learning model to try and predict, given the ad served, who wins and who loses, right? Based on this cookie information that comes from the user. Now, on the control side, what happens is we still get the information from the ad exchange, but we don't bid. We don't spend money, we don't bid. We just save this information down. And then what we do is we use the machine learning model that we trained on the treatment side of things to predict wins in the control side. And once we predict which user IDs would have won, we can take those user IDs to the Dove Soap website and find out who converted for them, right? And in order to kind of be fair on both sides, we don't take actual wins. We actually run the machine learning model on control, on treatment as well, and get a set of user IDs, go to the Dove website, get the number of conversions, and we measure lift. So it's a simple lift calculation, the unique number of predicted impressions in treatment divided by the unique number of conversions in treatment, and then same in control, -1, you get the lift. And we didn't pay a cent for control. So this is an innovative method where we provide to our advertisers the opportunity to do an A/B test, but not spend on control. So here's some kind of results that I put in here. So in tactic 1, you can see that after this kind of method is completed, you can see there's actually no significant difference between treatment and control. But in tactic 2, you actually see an 18% increase in treatment. So that's great for the advertiser. Okay, so that kind of brings me to the end of my talk, and I'm at 50 minutes, I think. So I just want to leave you with some opinions on running successful data science teams. So here, these are all my opinions based on my experience and information that I have. First, be sensitive to diminishing returns. So for example, when you're building a machine learning model and you're at AUC 0.95, you can put a lot of effort, a lot of headcount, a lot of time, and get to AUC of 0.8 or 0.98, right? But in that kind of change, you need to also measure how much difference does it actually make for your customer. Or whatever goal that you're trying to achieve, because chances are it might not actually make that much of a difference. So be sensitive to diminishing returns and wasting time. Second, don't be afraid to build, but don't reinvent the wheel. Just like in the case of Wine Express, who went out and outsourced their A/B testing, right? In kind of software projects, if you take examples of software projects, there's a lot of open source code out there. Sometimes as engineers and research scientists, we like to build stuff. Like, we just jump in and say, I want to build this. But sometimes it's good to kind of step back and say, these are the open source code that is there. Let's just use it and then build the stuff that we really need to build. So don't reinvent the wheel, but also don't be afraid to build. Having a complete timeline, for me, has become a very critical component of success. So if I'm planning a team and if I'm planning a project and leading a team, I always have a complete timeline, sometimes for the whole year, because this consolidates my plan. It tells me where my launches are. It tells me where my beta testing dates start, right? And it kind of gives me a consolidated plan with which to go with. It's easy to strategize then. For example, like, if I want to create a certain strategy, I want to make sure that I achieve this much of performance by so-and-so date so that I can see this growth. It's easy to strategize because I have a timeline. It's also easy to evangelize. If you want to talk to another person and say, I need your help, but I need this help by so-and-so date, because if I don't get this help by this date, I'll never make my deadline because I have a timeline. Sometimes it doesn't, if you don't have a timeline, it's hard to say that. So it's easy to evangelize. Partner with other teams. When you're doing cutting edge work, it's always helpful to just partner with other teams, because when you build the most successful products when you build them together. I know that for Datastorm 2.0, this might not work because obviously it's a competition, but in other cases, it's very helpful to partner with other teams. Giving credit is extremely important. When you're at the cutting edge, when you're building things get a little competitive, right? Especially within teams. But it's extremely important to give credit to the people who actually do the work, because that's how you build a healthy team. It's ethical and it's healthy. And also, finally, think big. This is one of the core Amazon leadership principles, where you have to think big. If thinking small is a self-fulfilling process, so you think small and then you achieve it and you feel good because you've achieved it, and you just think small again. It's not a good way to go. Think big. Even if you fail, chances are you've grown much more by thinking big than by thinking small and achieving it. So with that, I can conclude my talk, and I'll be happy to answer any questions as best as I can.
Okay, thank you very much for that insightful presentation, sir. As we have received some questions, I think we can move on to the Q&A session. Before moving on, just a quick reminder for you guys, there's a link available in the chat section. So if you have any questions, feel free to ask them using the following link. So let's move into our questions. Our first question is, how to know whether the data we have obtained or collected from the internet or by a research is enough for a data science project?
That's a really good question. So I know, yeah, there's a lot of projects where you scrape data from the internet and kind of do something. Let's see. So typically, when we are building models, usually one of the ways that you can kind of identify if you have enough data is by analyzing the variance of your results, right? So for example, if you have a certain result, and typically like for machine learning, people don't do this enough, but you can measure variance of your results. So you can make a prediction and you can run it several times and see whether there's a large variance. And if there is a large variance, usually that means that your model is not as stable as at predicting than if it had more data. So it depends on how much variance you're okay to live with. But usually, if you want to slim down that variance, you can actually scrape more data or get more data in order to build your model. But also at this point, I'd like to kind of point out, in certain cases, in certain pipelines, if you have a lot of data to deal with, you have latency issues, right? So it's kind of like a balance that you have to be sensitive to. Some of the models that we use cannot be used. For example, in my AdTech kind of example, we used a random forest instead of a neural network, for example, mainly because AdTech is so fast, it just needs to run faster. Latency issues cannot kind of block us. So in another case is when you have a lot of data, if you're processing it in real time, obviously there are latency issues. So you have to kind of keep that in mind as well. So that's the balance. But I would say to figure out like how big your data should be, you can look at your results, you can look at your variability as well.
Okay, sir. So the next question is, what are your thoughts on business decision making based on Facebook and Google Ads data? As per the knowledge, the algorithms used by these platforms are updated on a regular basis. So is it wise to trust the data and the output that is given by this data?
So I'm not sure I completely understand the question, because I would say if the algorithms are updated regularly, it would be okay to trust them. For example, like if they're not updated regularly, it might be, erroneous in its targeting because it doesn't have the most modern data sets. Hypothetically speaking, and this might not be information that is taken by these models, but let's say, for example, you're using 2019 data to predict something now, especially in NLP, for example. It's pretty bad because COVID-19 didn't exist in 2019. But now COVID-19 is such a big topic that if you don't include it in your models, there's going to be huge issues. So that's a case where like updating your model is actually good to get a better result. So maybe I didn't understand the question correctly, and feel free to kind of put another question and clarify it for me. But I would say if it's updating regularly, it would probably be okay to trust it.
Thank you, sir. Guys, you still have time to ask your questions, and the link is available in the chat section. So feel free to go and submit your questions there. Okay, so let's move into our next question. So how do we care about user privacy when collecting data? Are there any steps that we should follow when collecting data?
Yeah, that's a very, very good question. User privacy is an extremely sensitive issue at this point of time. And yes, you have to be extremely careful. Like out of the two examples that I gave, healthcare would be probably the biggest place where you have to be very, very careful. So usually the health plan, like for example, even at the health plan level, or even if they hire a team, they usually de-identify the data. So one thing that you can do from the offset is, if you have any specific customer data that you're using, make sure you de-identify it. And that is if you're a website or something that has real paying customers who have agreed to kind of, share their data or something like that. The other thing that is there is you can actually kind of get your customers to agree to share their data. This is sort of like the GDPR laws that are in the EU now prevent lots of these large companies from using this data without their customers' consent. So you can also opt to get your customers' consent when you're using data when you're using kind of sensitive data. If you're scraping the web or something, usually the web has open source data that is okay to use. But still make sure you check the license. So for example, if you go on the Kaggle website, or the Kaggle website is fine because the Kaggle website would already check their data sets. But if you're kind of pulling from any other place, especially like these papers or any other GitHub repository, just check if the license allows you to use the data, and especially for commercial purposes. Like if you're building some machine learning model for a company, you can't just pull data ad hoc. Like you really can't do that because, for example, there's some data sets that come with a license that says if you use this data set in your model should be public. So think about it. You build your model for the company, you train your model, and then suddenly somebody says, you know what, you tell your company to share your model because you use this data. So just make sure you check the licensing of the data set before you use it. And also, if you're a website or if you have your own customers, make sure you de-identify the data properly and make sure you kind of remove any private information. Especially like if you have like text data that somebody shares, you might have to actually build things that go step by step into that text data and check and de-identify. Because, for example, you might just de-identify the user ID, but the user might say something that says something like, Charith has a puppy who's 8 months old, and somebody will be able to easily figure out who that Charith is. So you might need to kind of build your own system to de-identify the data. I hope that answers the question.
Okay, so one final question. What sort of future do you see in Sri Lanka regarding to data science?
I see a great future in Sri Lanka. And the reason why I say this is I'm not super aware of the startup culture in Sri Lanka because I left Sri Lanka about 10 years ago and I've been working here since. Excited to come back at some point. But I know for a fact that I've seen a lot of people who have kind of founded startups and how are doing work in Sri Lanka. And there is people coming back from here as well with experience to startup stuff in Sri Lanka. And also data science as a field, it doesn't necessarily require much more than a good infrastructure, internet connection, and some computers, right? So it's kind of easy to start off data science related projects in Sri Lanka that can actually serve the entire world. One of the things that I realize now is like this last whole year, all of us have been working from home. Some companies like Facebook, Spotify have actually converted to models where their employees will be at home forever. This is causing a lot of people to leave the cities and move into suburban areas or even like far off into like, unpopulated areas and just do their work from there. So like you can see land prices are actually going up outside the cities because people are just moving out. Now, that doesn't prevent people from moving across the ocean as well, right? So I can see a lot of, small companies or data science projects might be able to kind of move across the oceans and, come to Sri Lanka and blossom there. So that's my idea. I'm not sure whether this is going to happen really, but I can see data science having a great future wherever you are in the world, just because all it needs is an internet connection, some infrastructure, and some computers and some bright minds like what we already have.